Alright, here's 4.4, solve rational equations, and I would do A, C, D, and F. They're the easier problems, and then on part 2, I'm going to do B and E. Okay, they're a little bit different with 3 terms, so we're going to do a few of them. We're going to be solving rational equations, is what we learned in class. Okay, so let's do a few first. Let's do part A here. Okay, so let's see here. We have part A. When we have a rational, so here if I cover this side over here, if I have a rational, I don't know what x is. I'm trying to figure out what x is. As a matter of fact, the instructions here, let me grab it. It says solve the following equations right here. Solve the following equations, and then state whether each equation has no real solution, 1 real solution, 2 real solutions, or infinitely many. So we are looking to solve for x and then decide how many solutions we get. So when I have 2 rationals like this, most students are already used to seeing this, and they say, oh, I remember this from Math 1. They call it the Hart method, they call it the cross multiply method. There's lots of students does different things. So I'm going to stick to what is most common to everyone, and we're going to do the cross multiply method. To me, as a math teacher, it's not the correct method. The language is not correct, but I'm okay with it, okay? Because it makes sense to the students. So we will cross multiply. I would multiply 6 times the x plus 2. Remember, the x plus 2 is a group, okay? And then we're going to multiply the 3 times the x minus 1. The students have seen this in Math 1, so they're used to it. It really doesn't matter which side you put which multiplication. It really doesn't matter. So I'm going to do 6 times the x plus 2 on this side equals, I'm going to put the 3 times the x minus 1 on this right side. It really doesn't matter which side you put things. Okay? Alright, so here we use the distributive property, something you learn in Math 1. And you distribute and you get 6x plus 12 equals, here we get 3x minus 3. Okay? Now, we are pretty much trying to solve for x here. I need to put the variables on one side and the non-variables in the other. So I'm going to subtract 3x from both sides. I'm going to end up with 3x plus 12 equals negative 3. And then I'm going to subtract what is not a variable to the other side. So subtract 12, and we end up with 3x equals negative 15. Since I'm trying to solve for x, I'm going to divide both sides by 3, and we get that x equals negative 5. Negative 5 is a real number, and that is the only solution we got. So we got one real, let me write real, one real solution, okay? One real solution, that's what we got here. That is the only value that when you plug it in to our original value here of x, it will make this rational, this fraction, equal this other side fraction. And we can plug it in just to see over here. If you have a 3 all over a negative 5 plus a 2 should equal 6 over negative 5 minus a 1. Okay? So 3 over a negative 5 plus a 2 is a negative 3 all over a 6 divided by a negative 6. This is a negative 1, which it does equal a negative 1. So there we go. It is. I'm just checking. This is just the check moment to make sure that I did my solution correctly. Most students don't bother to do the checking. They just believe their work. Sometimes it's just good to check, okay, to see if you made any arithmetic mistakes. I've been teaching for a little bit now, and I still make mistakes sometimes. All right. Let's do it one more time. Letter C. Just got to be careful with multiplying. This was letter A was a very easy example. Let's do B. I'm sorry, C. Okay, so I'm going to multiply the 2 times this binomial over here of x squared minus 8. And then I'm going to multiply the x times the x. Really doesn't matter which side you put it. I'm going to do x times x over here equals the 2 times the x squared minus 8. All right. So on this side, there's nothing to do. I just have an x squared. Here I have the distributed property to use. So I have a 2x squared minus a 16. All right, I want to put variables on one side, and I want to put numbers that are not variables, the non-variables, on the other side. I'm going to go ahead and subtract the x squared from here and subtract the x squared from here. I have 0 equals, I have 2 minus a 1 is just an x squared minus 16. Immediately, I see a difference of squares, and that is okay with me. Some students says, oh, I'm going to add 16 to the side. That is okay as well. 16 equals x squared. Or they immediately see a difference of squares. They see 0 equals x minus 4 and x plus 4. I'm just trying to do it both ways. However you see it is fine with me. If you take the square root on the left, you must take the square root on the right. And you get that the square root of 16 is a 4, and this equals the absolute value of x. So when you set this little equation, you see that x equals negative 4 and x equals positive 4. Those are the two values that when you put in here and you take the absolute value, you get a 4. Some students like to skip this and go straight to x equals plus or minus 4. That is okay with me as well. So there you go. There's so many ways of seeing this. And then here, if you set each of them equal to 0, you get that x equals 4 and x equals negative 4. Again, a totally different way of seeing the same exact answer. All right? So however you remember, this is using the definition. This is the most correct mathematical way of doing it, is by seeing the definition. Some students like to skip this way. That is okay with me. They keep the definition in their minds. And some students see as a difference of squares. Either way is fine with me, as long as it is correct. All right, let's do letter D one more time. I think this is becoming a little bit, the same here. You see what to do. All right, so we're multiplying 6 times. I like to put it in group because I don't want students to forget the distributive property. I'm multiplying by this over here, and we're multiplying, let me put it in group, the 2 times this other group over here, okay? So the 6 times the 3x, oh, I'm sorry, I need to go back to that question really quick. I forgot something. We have 2 real solutions. Okay, I'm forgetting the last part of it. We have 2 real solutions because a 4 and a negative 4 are real numbers. Okay, so here we got 1 real solution. Here we got 2 real solutions. I want you to see both examples. Okay? All right, sorry, back to this problem over here. So 6 times 3x plus 1 equals the 2 times the 9x plus 3. Let's see how many solutions we're going to get here. All right, we got 1, we got 2. Let's see what we're going to get here. All right, so let's distribute here. 6 times 3, 18x plus a 6 equals 18x plus a 6. All right. Well, it looks like the left side here equals exactly the right side. As you can see, I have 18x plus 6, and here I have 18x plus 6. So remember this, when the left side equals precisely the right side, they're exactly the same thing. If I subtract 18x from here and it subtract 18x from here, we get the 6 equals 6. Again, the left equals the right. If I subtract a 6 from both sides, which it's silly for me to be doing this, we get that 0 equals 0. We get a true statement here. As a matter of fact, this is the case that we're going to have infinitely many solutions. Okay? This is the case that we're going to have infinitely many solutions because we have exactly the same equation. So if I plug in a 2 here and a 2 here, I'm going to get the same answer. If I plug in a 100, I'm going to get the same answer. If I plug in a million, I'm going to get the same answer on the left and on the right. So this is the infinitely many solutions. If I plug in a 0 for x, we get 6 equals 6. Okay? If we plug in a 10 for x, we're going to get the same answer on the left as we're going to get on the right. This is the case where the infinitely many solutions, okay, is a true statement. This is true. This was true here. This is true here. It's a true statement right from the beginning. Okay? All right. So you saw when we get one solution. We saw when we get two solutions. We saw the case when we get infinitely many solutions. Now let's take a look at one more example. What happens here? Am I going to get one solution, two solutions, infinitely many? What are we going to get? All right, so let's cross multiply x times, let me put them in groups, x times x plus 3, and then we're doing 3 times the quantity of x minus 4. Really doesn't matter which side you're going to put things. I'm going to go ahead and do x times x plus 3 equals 3 times the quantity of x minus 4. All right, so go ahead and distribute on both sides. That's the distributive property. We get x squared plus 3x. Here we get 3x minus 12. All right, let's see. What do I want to do here? I want to go ahead and subtract this 3x from both sides. Minus 3x minus 3x. I end up with x squared equals negative 12. Nice. Immediately you should say, well, I want to apply the square root to both sides. But anytime I take the square root of a negative number, we are going to end up with imaginary solutions. So we already have a pretty good feeling of what our answer will be here. Okay? The square root reduces with the square. We get an x equals. Here we have the I. This is the negative 1 times 3 times 4. I hope that you can see that this is still negative 12, okay, if I multiply it all out. This is going to equal, the square root of negative 1 is I. I cannot take the square root of 3, but I can take the square root of 4, which is 2, and the square root of 3 has to stay inside. So the x answer is 2i root 3, which is not a real solution. There we go. So you saw all, I'm sorry, I forgot the plus or minus, plus or minus, plus or minus, and plus or minus, okay? Because we took the square root here, and I shortcut the definition of the absolute value. So you saw all 4 answers, 1 real solution, 2 real solutions, infinitely many, and no real solution. All right? You can go ahead and solve the rest of your worksheet. Now, on part 2, here, I just want to do one more problem for you. It says, part 2 of your worksheet says, solve the following equations and check for extraneous solutions. This is so important as we move on with rational functions. We need to check for extraneous solutions, all right? Solutions that does not belong in our solution set. All right. This does not look as simple as what we were doing before. It does not look at first, but we can make it happen, okay? I see that this x minus 1 here and this x minus 1 here, if they were by each other, I could make them work. So why don't I do that? Why don't I move this rational expression to this side of the equal sign by subtracting it? And why don't I move this rational expression to the right side here so I can get the denominators that are the same on the same side? So I'm going to repeat x over x minus 1, but I'm going to subtract this entire fraction to this side, minus a 1 over x minus 1. And this negative 2 over x, I'm going to add to this other side. Okay, so I'm going to have a positive 2 over an x. I'm shortcutting a little bit here, but all I'm doing is I subtracted this to the other side, and I added this to this other side. Okay? So now I have common denominators. Anytime I have common denominators, I can just take care of the operation in the numerator. So I would have x minus 1 all over the denominator of x minus 1, which equals 2 over x. All right. If you don't see it already, you can go ahead and cross multiply. It's going to be a little bit of work, but you're going to get the same answer as me. Immediately I see that x minus 1 over x minus 1 is exactly the same thing. They are reducible. Becomes 1 over 1 equals 2 over x. To me, I like this way better than this one right here. Some students don't see it, so they end up multiplying it, and they end up with the same answer as me. I see a 1 over 1. At this point, I already see what this x must be for me to get the same answer as 1 over 1. This x must be a 2. I would have 2 divided by 2 would equal 1 over 1. Okay, because I want both of the sides to be the same thing. If you don't see it, you can still cross multiply, and you see that 1 times x equals 1 times 2. X must be 2. Okay? Now, let's go ahead and take care of extraneous solutions. What x cannot be? X cannot be, if you look at the denominator over here, x cannot be a 0. Okay, x cannot be a 0. And x cannot be a number 1. Okay, so there we go. I'm just taking care of what the denominators cannot be. The only answer we got here is x is a 2. It is not part of our extraneous solutions, so we are good to go. That is the answer for this rational expressions right here. If you want to plug and check, you're welcome to do so. What I want you to see is that try to identify common denominators and try to put them on the same side. It's kind of like if you had 2/5 minus 1/3 equals, I don't know, let me make something up here, x over 5, okay? So if you had this right here, I'm trying to make a similar case here with this. You would wanted to put the x over 5 on this side, 2 over 5, and you would add the 1/3 to the other side, okay? And this would be minus x over 5, and this would be plus 1/3 to the other side. So I'm just moving things to other sides so they can be near each other with common denominator. There is another way of doing this problem, which is finding the least common denominator. I will show you as well how to do that in class, but most students like this moving things around, okay? All right, here's my last case. What happens if I cannot move things around? What happens if none of them I can put by each other by subtracting this to the side? What happens when that I have that case? This is the case where you have to find the least common denominator of all of these denominators right here. But in order for me to do that, let me factor this so I can see what are the factors of this trinomial. This is x over x plus 2 plus 2 over, I'm going to factor this, and I know that 2 times 3 gives me 6, and 2 plus 3 adds up to 5. So I know this is plus 2 and plus 3 equals the 5 all over an x plus 3. So there we go. Now I know that I have the x plus 2, and I have the x plus 3, and I have the x plus 2 times the x plus 3. Well, I have all these three denominators right here, and the common multiple of all of them is this guy right here, okay? I know that this x plus 2 times the x plus 3 is divisible by the quantity of x plus 2, and is divisible by the quantity of x plus 3, and is divisible by itself. So I know that this is the least common multiple. I am going to multiply every single one of these fractions by the least common denominator, okay? I am going to write x plus 2 and x plus 3. I am multiplying this fraction right here by this least common denominator. I'm going to multiply this fraction by x plus 2 times x plus 3. I'm multiplying it. And here I'm also multiplying x plus 2 times x plus 3. There we go. So every single one of these fractions, if I cover it, you see I'm multiplying this rational expression by this denominator. I'm multiplying this rational expression by this multiple right here. And I'm multiplying this rational expression by this common multiple right here. Since I'm multiplying it, it's very, very similar to what we did with the complex fractions. We're trying to clear all the denominators. So I have an x plus 2 right here, which reduces to this x plus 2 right here. So now I just have an x times an x plus 3. Plus, let's move on to the next case. Well, I have the plus 3's that reduces and the plus 2's here, the x plus 2 that reduces. We end up with just a 2. Equals, over here, we have the x plus 3 that reduces, and we end up with 5 times an x plus 2. Okay? Some of the students, they love this clearing the denominator method, and I love it as well. Okay? So here we go. Now we just need to take care of it by distributing over here. We get an x squared plus 3x plus 2 equals. Here we have a 5x plus a 10. Now remember, they're asking us to solve for the equation for x and then check for extraneous solutions. All right? So I'm going to subtract the 5x from here. And I'm also going to subtract the 10. Let me see if I get any luck here. Subtract the 10 from both sides. Okay. So here I have x squared minus a 2x minus a 8 equals 0. Wow, it was really complicated at the beginning. We were able to reduce and be able to come up to a trinomial. I know I can factor this and set it equal to 0 so I can solve for x. Okay? All right, I think of 2 times 4 gives me negative 8. Actually, it would have to be a negative 4 and a positive 2. Let me check it. If you multiply positive 2 times a negative 4, you get a negative 8. But if you add them, you get a negative 2. Now I solve for x by setting each of these equal to 0. X minus 4 equals 0, and x plus 2 equals 0. We get the solution that x equals 4. That's beautiful. And x equals negative 2. There we go. If you subtract the 2 and if you add the 4, these are solutions. But there is a problem. We got to check for extraneous solutions. Okay? What is it that our denominator cannot be? Because when I grab these two answers, I want to plug it in here in the denominator. But there's a few restrictions. Over here, if I put in a negative 2, x cannot be, let me see if I can fit the page on both. Okay, so x cannot, let me see right here. X cannot be a negative 2. X cannot be a negative 3. And we factor this to be a positive 2, right? This is a x plus 2 and x plus 3. So we know it cannot be a negative 2, it cannot be a negative 3. So x cannot be these two values. So when I check my solutions, I'm looking for these two values that cannot be. So, and here it is. X equals negative 2. No, this cannot be. I am not going to plug in this answer because it's going to cause a 0 in the denominator. So the only solution for this is x equals 4. This is the only true answer for our problem. Okay? So that's why we have to check for extraneous solutions. So hopefully that helps so you can solve the rest of the worksheet, and good luck.